In this video I'm going to address a few more things relating to pointers. Firstly, it's important not to get the size of a pointer confused with the size of whatever it is pointing at. It will have its own location in memory. After all, it's a variable in memory that stores the address of some other variable, for example. So it does have a size, and this could be 4 bytes or 8 bytes depending on your system. But the variables that you point at can of course have different sizes. I'll just create a few variables here. I'll do size of, and with each one of those we'll get the size of that variable in memory. So we have 2 for a short, 4 for an integer, and 8 for a double. Of course you can do parentheses as I mentioned, the type such as integer, like this. We discussed that previously. Okay, now I'm going to change all of these to pointers. So we'll not get 8 for the double. For example, it is simply a pointer that points to a double, but the pointer variable itself only requires 4 bytes. So once more we have this double here, right? And then I do a double pointer, which points to the address of this double variable. And then I print out these sizes. So we'll get a 4 for the pointer. On this machine I'll get a 4 for that. And then the double itself requires 8 bytes. So 8 for the double and then 4 for the pointer. Okay, let's say we have this struct called playerStats with a few variables in there. Each instance of this struct will have all of these variables associated with it. I'll just delete all of these. So I have the stats pointer to a player stats, and that is going to point to this player 1 here, this instance. And I go and do size of player 1 and size of stats. The stats once again is just the pointer. Build and run that, and you can see there's a big difference. So when it comes to memory usage, it's more efficient to use pointers because typically you use pointers to point to large objects that you have in memory so that you don't have to copy that entire thing. Because instead of copying 24 bytes now, I simply have this pointer created and that points to that object that already exists. And what's nice about the pointer is I can always change it to point somewhere else if I want to do that. So as you can see, a big difference between the size of a pointer and whatever it is that it is pointing at. This pointer points to player 1, which has 24 bytes in memory. So that is much larger than the size in memory for the pointer. So just a few more things here. Let's say we want to print out basically what stats is. Then we use it just like you do a typical variable. We have to remember that the pointer stores an address, so this is going to print out the address stored in that pointer. And just like with a regular variable, even though this again is a pointer, right, we can still get the address where that is located in memory by using the address of operator as we've seen. So we can do the address of stats, and that will then get the address of the actual pointer variable in memory. And of course we can do the size of, just like I explained previously. Just build and run that and you'll get the different values. I'll just add some inlines. So I declare an instance of this playerStats struct. I'll do another one, say player 2. Here we can do the pointer, and then we can assign it null pointer if we want to do that. Or what we can do is, you can go and change what that points to. So instead of pointing to player 1 now, it's going to point to player 2. We'll run that and you'll see what I mean. So this is what we get. The address of stats is right here. It ends with BD and 0 each time. So the address of stats is not going to change. So in other words, where the pointer is in memory is not going to change. So it's going to look different on your machine, and each time you run it, you'll get a different address. But during execution here, you can see it stays the same, but the value stored in stats is going to be different. So when we start off, remember it was initialized to player 1, so it stores the address of player 1. Then we set it to null pointer, so it's just going to store null. Then we change it to player 2, so it's going to store a different value now than what we had originally, and of course it also changed from null. So the point is, we can change a pointer variable. You can of course change a regular variable such as an int and a double and so on as well. So it makes sense that we can change the pointer variable. But what's very handy with pointers is, as you can see, we can make it point to something else or reference something else. Now we have a problem here in that, let's say I have some double. He will get an error because if you hover over this, type double cannot be assigned to an entity of type player stats. Once again, with a struct, we create essentially a custom type. And so this is fine, assigning player 2, the address of player 2 to stats, because stats, you can see here, is a pointer to a player stats type, right? Here I have player 2, this is of a player stats type, but here I have a double, and I'm trying to assign the memory address of that double to stats. So that's why we'll get an error. Again, you can try and build and run that. It's not going to work. I'll delete that. And as I mentioned, pointers can also be uninitialized. So I'll go and delete that. Build and run that. You'll actually get an error, uninitialized local variable stats used. Right here. Do that. And this will work fine because we get 0 now. 0, 0, as you can see. Remember that the empty list notation will return 0. So that's similar to doing this. Now what you can also do is use null. If I hover over this, you'll see we have bound define, null, and we have 0. And that is a macro. Basically all this macro is going to do is it's going to replace this null here with 0. You can see expands to 0. This is the same as doing 0 here. And it's not recommended to use that null macro anymore. Either use null as in 0 or the new this null pointer. Right, so that was just a bonus section on that. And I'm gonna clean up a bit here, because maybe not all of this comes across in the slides, right? So just an extra demonstration. So the point of this section was just to emphasize that pointers are variables once again, so they can change. What they store can change. They can be null, and they can also be uninitialized. So you want to avoid that.